All right. Hi, everyone. In the last video or in the last session, we covered a product design question. It was regarding how would we improve Instagram stories. So after that, I think what we can possibly cover in this round of preparation is a product estimation question. So product estimation question is pretty similar to like a guesstimate question, wherein the interviewer is interested in knowing a quantitative number for something. It could be give me the YouTube revenue, estimate the number of tennis balls that fits into an airplane, number of buildings in a city, number of sweets sold in a city, or similar. So product estimation questions are pretty much approach driven questions, not necessarily output driven questions. The interviewer is trying to understand the approach, how you break down the problem, and not necessarily the outcome. So what we can probably do is we can begin with our plan for today. And yeah, so for today, we covered the product design interview preparation, one section for that. Now let's do a 60-minute session for a product estimation session. I can start the timer for 1 hour. And now let me start looking at the questions for a product estimation. I have already shortlisted one question, so I looked at all of the product manager estimation interview questions, and then I'm looking at the most popular ones. And here we have one of the questions as estimate the number of restaurants in San Francisco. So what I'll do is instead of going for San Francisco, I'll calculate the estimation for the number of restaurants in New Delhi. And what we can do is, while talking to the interviewer, we can say that, okay, in order to estimate the number of restaurants for New Delhi, first of all, we can list down some clarifying questions so that we know all of the nuances related to restaurants, New Delhi. We align on a common goal. So this would be just the beginning, clarifying some questions and setting up a common goal so that both the interviewer and I are aligned on the same page. Then I would propose showcasing or sharing like a high level framework or like an issue tree in which I will talk about the high level details of this particular question. Like, how will I approach this question of estimating the number of restaurants? Followed by that, we could do the calculation of each and every bit. So let's say that the high level approach is estimating the number of restaurants in New Delhi is divided into three parts. So I would calculate the maths for first, second, and third part. Calculations done, then I combine all of the three parts, come up with a result, and then share the result as the end outcome. Now, when I share the outcome, I think one of the key things would be to also look at sense checking the result. So sense checking means, okay, if I say that the number of restaurants in New Delhi is X, is that X accurate? Is it somewhere in the ballpark range? So we could brainstorm our thoughts on the final outcome, and if there is any potential improvement, I could share those potential improvements. And yeah, I think that's pretty much it. Then we could summarize the discussion. Okay, so let's begin. So clarify some questions, align on common goal. Then it would be high level approach, then calculation, then result, like combine and share the result, then sense check the result, and finally summarize the discussion. Okay, so thinking out loud, estimating the number of restaurants in New Delhi, right? So first of all, I would like to know what is a restaurant. So let's define a restaurant. Then let's also define the scope of New Delhi. And list any other assumptions. So I do not have any assumptions right now on top of my mind, but let's begin with clarifying what a restaurant is. So if I can probably segment restaurants in New Delhi, there would be obviously different types of restaurants. So let's think of them. The first one would be more like a high-end restaurant. It's dine-in, and obviously there is a dining. The restaurants they have a proper physical outlet, and it's sort of above average to expensive range monetarily. Then there would be fast food chains such as McD, KFC. So these are average expense range. What else? Then there are small, medium business restaurants. These are more on the lines of dhabas, um, small North Indian or any cuisine, any cuisine places. These are also below average to average expense range. And there are also coffee shops, um, coffee shops, not burger, but let's say coffee shops, breakfast places, or tea shops, etc. So they are not necessarily restaurants, but let's keep it here. And then finally, we have street vendors. They do not have a shop. Um, they do not have a shop, and they sell fast food, generally fast food items. So for the purpose of this conversation, maybe what we could do is we could keep coffee shops and street vendors out of scope, and we can probably include the first three into the definition of a restaurant. Okay, scope of New Delhi. Let's include everything within NCR. So I do not know much, but maybe these are all Delhi NCR cities. Um, okay, what other assumptions do we have? Now, there would be a certain type of occupancy in different types of restaurants. So occupancy must be assumed when doing the calculation. So this is one. And occupancy also varies by time. So lunchtime, dinner time, weekdays, weekends, it all depends. So just to keep things simple, and occupancy would also differ by type of restaurant. So we could say that occupancy depends on weekday versus weekend. It also depends on area density slash area busyness. Okay. Uh, area density, I would say, mostly. How busy the area is. How busy the area is. It would also depend on meal of the day, meal time of the day. What else? Weekday versus weekends, um, area density. It all also occupancy would also be different for type of restaurant. So type of restaurant would also determine the occupancy. So maybe because there are so many parameters, what we could do is we could keep things simple and average things out at a higher level and just come up with some average occupancy, um, and take upper bound of weekend and busy area and uh, most busy time of the day, maybe like a dinner. Okay, so these are at least my assumptions. Now, what we could do is we could let's align on a common goal. So the common goal here is estimate the number of restaurants, obviously. And here restaurants mean high end plus fast food chains plus SMBs in Delhi NCR, and upper bound or so on a weekend, um, busy area and busy time, something like that. Okay. So high level approach. Uh, uh, um, okay. So one approach could be going through the population route. So let's say number of people in Delhi NCR, then number of people in Delhi NCR, then number of people in Delhi NCR that go out to eat in a restaurant. Okay, so we could say that they go out to eat overall versus in a restaurant. Now we know the demand side of things. We know how many people are going out to eat in a restaurant. We can, okay, then we could say capacity of uh, an average restaurant. So let's say this is A, this is B, and this is C. Our answer would be B upon C. Capacity of an average restaurant. With this includes occupancy and by type of restaurant. Okay, so this is approach one. Maybe another approach could be approach two. Mm, okay. Area of Delhi NCR. We we could also do here something like by density, high, medium, low. Then could also do high, medium, low, and commercial, residential areas. Which essentially means total, there would be six combinations, six area combinations. Second would be number of restaurants in each area, average number of restaurants in each area. Answer will be sum of A times B. Yeah. Okay. So I'll probably go with approach one, basically the demand approach. So here we are not necessarily calculating the number of restaurants, but we are assuming that if there are these many people and they need these many restaurants, the number of restaurants are available. So maybe we could begin with the assumption that demand, we calculate demand and map it to the number of uh, restaurants. Usually demand should be higher. Demand should be higher than supply. So we can put a haircut. So we can put a haircut at the end. Okay, so for A, number of people in Delhi NCR. So this is something I probably know on top. So India's population is what? 1.4 billion. New Delhi is the capital. There would be like 6 to 7 metropolitan cities. So 10 big cities. Um, okay, no. So 30% is urban. So 42. So 420 million population is urban. Now, tier 1 versus tier 2 urban. My assumption is that tier 1 cities are like what? Um, tier 1 cities are probably 60%. Well, let's just assume 50% each. Then, so which means 210 million population tier 1. Now there are 5 tier 1 cities, which means roughly 40 million population per city. Now Delhi is the biggest one, is bigger than others. So I would assume maybe instead of 40, it's something like a 60 million population. Okay. Then number of people that go out. I would probably divide the New Delhi's population into four buckets. Um, for lower middle class, upper middle class, and rich. Poor would probably have 20%, lower middle class 40%, 30%, 20, 40, 60, 60 plus 30, 90, and maybe the remaining 10% is rich people. So these folks don't go out to eat. LMC people probably 1 in 4. So 1 in 4, which essentially means 25%. So 40% times 25%. UMC 1 in 4, maybe 1 in 3 or 1 in 2. Maybe let's do 1 in 2. So 30% times 50%. Or instead, let's not do 1 in 4, 1 in 3. Let's do 40%. And then there is rich, that's contributing 10% of the population. They probably go out. Oh, no, I think probably go 50%, and these folks would probably go like 75, 80%. Okay. On any given weekend. So the total population here is how much? 25 fours 100. So this is 10%, which means this is how much? 60%, 60 million times 10%. This is 6 million. Next, we have 30%, 50%, which is 15%. This is 10, 6, 9, 9 million. Next, 7.5%. This means there's 75 into 6, which is how much? It is 75 to the 150, 150 into 3, 450. So probably like 4.5 million. Okay. So the total number of people total going out to eat will be how much? 15, 19.5. Let's assume 20 million. This is again upper bound. Now total going out to eat in restaurants would be, so now the lower middle class 6 million times maybe like a 75 percentage population would, no, 40 percentage population would go there. 9 million times 75, yeah, and then 4.5 million times, I would just say 100%, which means we have how much? 64, 2.4 million plus 80%, 72. Let's assume roughly 7 million plus 4.5 million. This is how much? 7 plus 4, 11 plus 2, 13, 13 plus 1, 14. So 14 million population is probably going to out to eat in restaurants. Okay, so this is B. Average capacity of a restaurant. So a restaurant, we had three types. Three types were were these three. Let's talk about high-end restaurant. Average capacity would be how much? Like a 120 people. Then occupancy percentage would be hmm, on a weekend, maybe like a 60%. So total capacity served 72 people on a weekend. Now let's do the same thing for fast food chains. Let's do the same thing for SMB folks. Fast food chains, maybe like 100 people, 80% occupancy, 80 people served. This is per hour. Um, per hour. So maybe for a day, this becomes 72 times, just assume like 5, to be honest. Yeah, and 44, that is a 10, 1, 36, 360 folks. 360 people per day. Like, let's go for the same number of hours. Here, maybe like a 40 people max. Occupancy 40 again. 16 people served. 16 people served. 80 people served per day. Yes. Should be a bit more. 640. This could be fine. Okay. So, restaurants 360, 1080. Total people served 1080 per day. Uh, 14 million. 14 million divided by 1080, which is equal to how much? This is these many. So 1080, this goes away. 14,000 restaurants. Okay. 14,000 restaurants. Seems a bit low. Seems a bit low. Well, let's see. And probably reduce, yeah, these be. So let's do 80 people. So 48, 48 times 5 is how much? 44, 240, 880, 6,000 people, a bit too high. Yeah, 800 maybe. So 14 million divided by 800. This goes away. This goes away. 140, 14,000. 14,000, one more zero divided by 8, 17,500 restaurants. Okay. So 14,000, oh, sorry, 17,500 restaurants. Checking the result, I think the number of restaurants, like, eateries look fine, probably a bit low, probably a bit low. We could probably use approach 2 here, approach 2 to sense check. Mm, if the area, what is the Delhi NCR area? 55,000 kilometers. Delhi NCR area is 55K square kilometers. So in one restaurant in 1 square, feels low. And it depends on the area, depends on the depends on how busy the area is. So probably like my hunch would be one restaurant, one per one restaurant per square kilometer would be would be digestible, would be in range. So more like 50K restaurants in Delhi NCR would be my guess. Okay, so uh, to summarize, we started with estimating the number of restaurants in New Delhi. We clarified some questions, got to a common goal, also aligned on some high level approach. We went the population route instead of the area route. And then uh, within the population route, we calculated number of people in NCR that want to go out in and eat in a restaurant, and then capacity of an average restaurant, calculated the number of people, 60 million, calculated number of people that want to go out and eat in a restaurant, then capacity, total people served per day, combine and share the results and check the result. And we probably are thinking somewhere around 20K to 50K restaurants in Delhi NCR. All right. Sounds cool. Now we have 25 more minutes. Let's actually look at some of the answers on the portal. Clarifying questions. What is the exact definition of a restaurant? Hunting coffee shops, home food shops, deliveries. Let's assume that we only mean restaurants that people can go inside and order some food and eat. Okay. Let's not consider bars and coffee shops. 2 hours per day. Another question. What do we count as a meal? Can I assume that breakfast is usually served at coffee shops or small bakeries, and we should consider restaurants that serve lunch and dinner mainly? Okay. Supply and demand rule. How many visits happen to a restaurant in each day? For more clarification, single person visits a restaurant, it counts as one. And if a group of friends or family visits together, also counts as one. Because they all sit at the same table and it is one visit. Later, I would like to calculate the number of visits each restaurant can serve each day. Top equation, number of visits, number of service an average restaurant can serve in San Francisco, number of restaurants in San Francisco. Like to calculate the demand on a weekend day. Since our population is 900K, another 100K for tourists, 1 million number of households, 1/3 of a million because family size is 3. Mm, 120K. Assume that about a third of these families would visit a restaurant on average 40K visits. Number of non-households remaining 700K. 1/3 of a population, 700K. They're single adults, they have a job, high salary, would visit a restaurant. 80% would visit a restaurant, and about 50% would visit in an average group of 3. Okay. So number of visits is 420K. 20 tables, 10 working hours, 1 average visit length. Average visit is 1 hour. Ah, number of restaurants A by B, 3,500. per hour. Yep. Think more or less on the same lines. My top level equation would be number of restaurants per square kilometer, number of square kilometers in San Francisco. I would like to break down areas in San Francisco in low densely populated, moderate densely populated, and high densely populated. Now, if I walk 1 kilometer in the high densely populated, I will see at least 30 restaurants, 15 restaurants, 5 restaurants, 13, 15, 5, 50 divided by 3, 17. I know for a fact that total area of San Francisco is 600 kilometers square, 10,200 restaurants. I think the number appears a bit too high in my view. I think my assumption around number of restaurants should have was in, I would like tweak 20, 10, 5, 6,600. Distribution of very likely not equal and will introduce inaccuracy. Some areas in San will animated, for example, a reservoir lake. Ah, yeah, this is interesting. Should have counted for it. Number of restaurants in Delhi NCR. Okay, 9. 32K are organized. So I think 32K is what we're looking at. 32K, not so 32K, 17. Yeah, I mean 50K. Sounds more or less in the range. Cool. All right. We can pause at least for this question and also stop our timer. But yeah, sounds cool. Maybe we could have gotten into more nuances. Let's check this again. Can start the timer again. So I think this would actually complicate things more, and we could estimate the estimate the number of restaurants in a better way. A weekday versus weekend, area density of how busy it is, meal time such as lunch, dinner, you see type of restaurant, because sometimes malls, like we saw in this question, malls could potentially have 30 or more restaurants in a kilometer square. So which is true. I think these nuances would obviously change the answer. For the approach to area of Delhi NCR, yeah, I mean, let's try this out. How would it look? Area of Delhi NCR, high commercial, so high density, commercial, high density, residential, medium, medium density, commercial, medium density residential, then low density, I would say commercial 0, low density residential. Okay. So total area is 55,000 square kilometers. Hmm. High density commercial, maybe like a 10% area. High density residential, 20%. Medium density commercial, I would say 20%, 30%. Okay. So 50, 70, 80. I think this should be 5. This should be 10. This can probably become 15. No, I guess 20 is okay. So this is 15, 65. This is almost 0. Low density residential, I think it should be like a good percentage. 20. Yeah. So 50, 70, 80, 85. So let's make this 25, 15, 25, 40, 40 plus 50 is 90. Okay, let's do this. High density commercial per kilometer square, maybe 30 restaurants. Your high density 15, 20. Say 5, 2, 0. Okay, so let's do this. 55, 5.5, 2.8, 28 into 3, 74. 0.8 into 30, so much. Into 5%, 2750 times 30, What? 82K restaurants. Interesting. Maybe I'm overestimating this. Should not be that high. 20, 10, 3, 3, 1, 1, 0. Yeah. 6K, 55K into 15% into 3, 24K. 20% times 3, 33K. 30% times 1, 16K. And this is 0 and 0. So basically 56 plus 24, 80, 110, 130K restaurants. So total 130K restaurants. Seems a bit high. Does not does not really look like either I have gotten the areas right or the average number of restaurants, which actually brings me to this assumption to potential pitfalls that the distribution of the areas in these groups is not very likely to be equal and will introduce inaccuracy in the final value, which is kind of true. And some areas will be inhabitable. So, for example, areas occupied by reservoirs, lakes, and hills, which is true. And the population density will be negligible in those areas, which I have accounted for. But again, I think the first potential pitfall mentioned in that is going to be true, and that has bloated the number significantly. But okay, I mean, could have this here. And yeah, okay, cool. Think that's pretty much it. This is what we have covered. 2 hours today. And yeah, maybe we could cover something else, some other type of a product design question, or um, maybe like a product strategy or a root cause analysis question in the next one. Cool. All right. Thank you so much. Bye.